Hello, dear students. Today we'll discuss about the chemistry of some of the non-metals like boron, silicon, phosphorus, etc. So, among boron compounds, diboron is one of the important chemical compound which consists of mainly boron and hydrogen atoms, and it has molecular formula B2H6. This substance, which is highly unstable at the room temperature, it is with a pleasant odor or sweet smell, and such type of compounds containing only boron and hydrogen atoms are called as boranes. So diboron is one of the simplest boron hydrides, and these they mix well with the air and form explosive mixtures, and which will ignite rapidly at the room temperature. And the other names which can be given for diboron are boroethane and diboron hexahydride. And this is the actual structure of diboron, wherein we can see these are the two boron atoms, and totally 6 hydrogen atoms are there: 1, 2, 3, 4, 5 and 6. And this is the actual picture of the diboron, wherein you can see the 4 hydrogens, they form bond in the plane of the molecule, and 2 hydrogen atoms, they form bridge bond between the 2 boron atoms. So let us start the discussion on the structure. So as we have seen, the diboron molecule contains 4 hydrogen atoms and 2 boron atoms which come in the same plane, and in between these two planes there are 2 dividing atoms of hydrogen, and the boron atoms which are present in diboron are sp2 or sp3 hybridized, and they have 4 hybrid orbitals. So from these 4 hybrid orbitals, what we can see, the 3 of the orbitals have 1 electron each, and of which there is 1 empty orbital also. The 2 electrons of the hybrid orbital in each of the boron atom form 2 bonds with 1 hydrogen atoms. So these 2 atoms of boron left with that of each unpaired electron orbital, and empty orbital forms the 2 bridgings between boron, hydrogen and boron bonds with that of 2 1s hydrogen atoms. So this type of bond is also called as banana bond. So if you want to see the structure, it can be described by molecular orbital theory, which tells about the bond between the boron and the terminal hydrogen atom is of conventional 2 center 2 electron covalent bond. The bond between the boron and the terminal hydrogen atom is of the type 2 central, 2 center and 2 electron covalent bond. The bonding between the boron and the bridging hydrogen atom is however different from that molecule which is observed in case of hydrocarbons. So each boron uses 2 electrons in bonding form with terminal hydrogen atoms and has 1 valence electron remaining for additional bonding. So this type of bridging hydrogen atom provide 1 electron each. Therefore, the B2H2 ring, which is held together by 4 electrons which form 2 3 center 2 electron bonds. So this type of bond is sometimes called as banana bond. So if you see the bridging hydrogen atom, they provide one electron, and these form bond with 2 electrons of boron. Totally the 4 electrons. So you can see totally the 4 electrons are involved in the bridging bond between the boron, hydrogen and boron. So this type of bond is called as 3-center 2 electron bonds. So which is also called as banana bond. So if you see the properties of diborane, see it is a colorless and highly flammable type of gas at room temperature, and at higher concentration it ignites rapidly in presence of moisture, and it smells sweet. The boiling point of this is about 180 K, and it is a toxic gas as it releases huge amount of energy when burnt in the presence of oxygen. We tell it also hydrolyzes in water to give hydrogen and boric acid. So if you take the preparation, one of the important preparation is the reaction involves the reaction of iodine with sodium borohydride in decline and produces diborane in small quantities. That is 2NaBH4 plus I2 giving B2H6 plus 2Na. This is diborane and this is sodium iodide, and the enormous amount of hydrogen is released. On heating, magnesium boride with hydrochloric acid HCl, a mixture of volatile boranes is obtained. So this is Mg3b2 is nothing but magnesium boride. In presence of 12 molecules of hydrogen chloride, it forms 6 moles of magnesium chloride, and this is a mixture of diborane, volatile borane, that is B4H10, plus hydrogen gas is released. So this in presence of hydrogen, it gives 2 molecules of diborane. So if you take the chemical reactions or chemical properties, usually pure diborane does not react with air or oxygen at room temperature, but it gives B2O3 together with large amount of energy in impure form. B2H6 plus 3O2 is equal to B2O3 plus 3H2O. This diborane, when reacts with methyl alcohol, it gives trimethyl borate. So B2H6 plus 6CH3OH giving 2BOCH3 thrice plus 6H2. And it forms metal borohydride when treated with metal hydrides. So reaction with ammonia, this is very important reaction. Diborane, when treated with excess of ammonia at room temperature, it gives borazole. And one more important reaction of diborane is the hydroboration reaction. So diborane adds alkenes and alkynes at room temperature in presence of ether as a solvent. So this reaction is called as hydroboration reaction, which is commonly used in synthetic organic chemistry, especially for addition of anti-Marconic product. So B2H6 plus 6RCH double bond CHR giving 2BRCH2R thrice. So this is the adduct which is obtained after hydrolysis. It gives corresponding alkenes or so at the triple bond or double bonded side, this B2H6 is added, and this is the addition product which is obtained, and we call this as a hydroboration reaction. Some of the uses and applications of diborane, if we tell, this diborane has a very important application, and that is it is used as a rocket propellant, and it is used in the manufacture of borophosphosilicate, which is a form of glass, and for chemical reactions it is employed as a reducing agent, and it is also used as a catalyst and rubber vulcanizer in the polymerization reaction. One of the important application is it is used as a doping agent in the manufacturing of semiconductor devices. So with this we have completed the first part of the chemistry of the non-metals, that is compounds of boron. Thank you.